Hi everyone, it's Brendan, and today we'll be doing 30 days of Solidity, day number 12. And I have copied the task description over here. Essentially, today we'll be implementing an ERC20 token. Right? This is going to be extremely easy because the work is already done for the most part in a library called OpenZeppelin contracts. Right? So all we've got to do is import it. Let's make sure, right, there we go. OpenZeppelin, oops. OpenZeppelin / contracts / token / ERC20 / ERC20 dot sol. And that really just gives you everything, right? So we've done imports before. Now we're just going to do inheritance, right? So we have that. So actually, let's change this to be use an explicit import, right? So we're importing ERC20 from OpenZeppelin ERC20, and then we simply need to implement the constructor, I believe. So constructor uint 256 initial supply, and then invoke the ERC20 constructor, right? And actually the ERC20 constructor, let's open that up. All right. Let's go. I believe the constructor requires something. Let me just search for this. Right. There we go. We need to pass in the token name and the token symbol. Right. So I'm going to go with right, and then that will satisfy the constructor. So essentially, the constructor of my first token is calling the constructor of the ERC20 implementation within this library, right? Now I need to call an internal function called mint, right? And that will mean that is essentially creating new tokens, right? New numbers of tokens, and then transferring it to a particular to a particular address, right? So whoever invokes the constructor, right, which is whoever deploys this smart contract, that account will get the entirety of the initial supply. That's how this smart contract works. All right, then we go function decimals. So by default in OpenZeppelin, the value of decimals is 18, right? And I just want to set it to 0. I don't want any decimal places. Right, so let's go to decimals. Right. There we go. So I'm just going to copy paste that and return the value that I actually intended to be, which is 0. So that's the important part, right? I'm making this override, and I can get rid of the virtual because I don't want that. And yeah, it can be pure as well. So it'll return 0 instead of 18. The default implementation returns 18, right? So that means 1 unit is equal to 1 unit, not 1 unit is like way where you need 10 to the power of 18 way in order to get 1 full unit of a particular thing. All right, let's compile this. So compile, no errors, and then I will deploy. So let's say I want 1 million tokens, and since I have no decimal places, I can just put exactly 1 million over here, press deploy, and I have a unit of my first token, right? So it's got all the things. I've got 0 decimals, the name is BGUIZ token, and the symbol is BGZ. Total supply is indeed 1 million, right? Now we can also check the balance, right? So I'm going to use balance of the current address, and that is 1 million. Now let's say I want to transfer this to the second account. So I'm currently using the first account to deploy it and also have the entirety of the initial supply. I will transfer of my entire stash 1 million. I'm going to transfer 1,000 over. So I will have 990,000 left, right? So if I repeat balance of, I have 99,000. Oh, sorry, did I get the number of decimals right? Yeah, okay, that's my bad. So I deployed with an initial supply of 100,000. No big deal, right? So 99,000, I still have it, and then 1,000 is in the second address, right? So let's just verify second address balance, and balance of is 1,000. Very simple. All right, then what do I want to do next? Yes, I want to transfer an amount that I don't have. So this, I'm going to switch to the second account, right? And I'm going to transfer to a third account, right? And I only have a balance of 1,000, but I'm going to try and transfer double of that, right? So 2,000, and it should reject, right? There we go. ERC20 insufficient balance. Great. Okay. Now what I'm going to do is I'm going to check that this third account doesn't actually have a balance. Right. There we go. Balance is 0. Okay. So that very quickly demonstrates the ERC20 token standard, which was actually implemented in OpenZeppelin. The docs are here, right? OpenZeppelin.com, and that is like one of the most widely used and highest quality smart contract implementations for common things such as tokens, and this makes it so much simpler. Like I can implement a token in much shorter time than I would be able to otherwise. All right, that's it for today. Thank you for listening.